this calculus question. So if you see here, this is a maximization question. We're trying to find the area of the largest rectangle with one corner at the origin. The opposite corner will have the coordinates x and y, but y is going to be based off of the function f of x equals 162 minus 6x squared, right? So what we're going to have to do is to find the maximum area. First, we're going to have to see, well, what's the area formula? Well, the area formula was, again, since one corner is 0, 0, and the opposite corner is the coordinates x and y, the length and width are going to be x and y respectively, right? So the area is going to be x times y, and we can translate y then into that function that we had before. So now we have to find what's the maximum area. And this function is clearly, if we look at it, let me just rewrite it one last time. We have negative 6x cubed, right, plus 162x as our function, right? And we're trying to add this equation to the board, right? This function right here, this equation is going to have to be as big as we can make it. And the way that we can make it as big as possible, because if you look at this thing is going to be, at least in the first quadrant where x is a positive number, right? It's going to be decreasing very rapidly by that x cubed term, but also increasing slowly by that 162x term. So one way we can find where there's a maximum is we can look at the derivative, because if we plotted this function now, we would see that there's some kind of curvature, and then there's going to be a point where we curve off to the top, right, for our area, and that's the maximum area that we can have, and then we're going to start curving downward. So if we look at the derivative of this function and look for the point where the curve stops and we're at our top area before we start curving back down, that's going to be the point where we have a maximum. So we're going to look for, when we take the derivative of this function, the point at which this derivative is equivalent to 0. So let's first take the derivative. We'll take the derivative of this function, and since this is just a simple addition, we're going to use with linear terms, we're going to just use the power rule, which is, remember, we take the exponent and we multiply the coefficient by it, and then we reduce it by 1. So our first term in our first order derivative is going to be negative 6 times 3, so that's 18x squared, plus, and then let's see, our second term was 162x, right? So we're going to, this is just going to turn into a constant, right? Because when we take derivatives of linear terms, right, they just turn into constants, right? We remove the x term because it was x to the 1, we multiplied by 1, we got rid of x to the 0, now it's 1, right? Okay, we can use the power rule for that, and we get this, right? So here is our area function now. We get negative 18x squared plus 162. So now all we have to do is find the point where this is equal to 0. So we set this equal to 0, right? Set this equal to 0, and then the next thing we're going to do from there is we're just going to solve it. So now we have, let's just divide both sides, because we're going to have negative, we're going to have x squared, and wait a second. We're going to have, let's move the negative 18x squared. So we're going to have 162 equals 18x squared, right? And then if we take 162 and divide it by 18, we get 9. So now we have x, so 9 equals x squared, right? And so then our final thing is we're going to have to say that x is equal to 3 in this case again, right? So x equals 3. We can add to that equation, right? And we're not saying negative 3 because we said we wanted to be on the positive side, right? So now all we have to do with this is then plug everything back in. So since x equals 3, we can plug 3 back into the original area formula, and that's going to give us our final answer, and we'll do that now. So 3 squared is 9. 9 minus, so 9 times 6 is 54, right? So then 162 minus 54. So 162 minus 54 is 108. So then it's 108 times 3, right? So 108 times 3, right, is equal to 324. And that's going to be our maximum area, 324, right, is going to be the area of our rectangle.